What's going on? Today we will be talking about SSRF or server-side request forgery. Now, in previous videos we talked about SSRF and we solved challenges from TryHackMe. In today's video I'm going to explain what is SSRF, and I found an example that actually demonstrates this vulnerability in a practical method, which is HTTP Kotarak or HackTheBox Kotarak. So by definition, SSRF is a server-side request forgery where an attacker is able to control, manipulate URL parameters. So basically they are able to control parameters in the URL in order to access internal resources, much like the IDOR vulnerability or similar to file inclusion, or discover hidden services, as we will see later in this video. Now here I have the section repeated. No worry about this. Now the example that we will take is a machine from HackTheBox called HTTP Kotarak. Now in this machine we will run an Nmap scan. By running an Nmap scan we will find several open ports actually, but the two noticeable the most noticeable of them are the 60,000 and 8080. 60,000 port runs the SSRF vulnerable service, as we will see, and 8080 running Tomcat. Now after we exploit the SSRF vulnerability on this and application running on this port, we will find credentials. The credential will be used to access the Tomcat administration panel. Through the Tomcat administration panel we will be able to get the first shell by uploading a payload that will return a connection back from the machine. After accessing the machine, we will do privilege escalation to root by exploiting a vulnerability in an old version of the popular tool Wget. So let's now jump to the machine and demonstrate the practical side of this video. Okay, so here we go here. So this is the Nmap scan, and as you can see we have port 22, port 8009, port 8080 running Apache Tomcat, and port 60,000 running Apache HTTPD, which is also a web server. Now by browsing to the port 60,000 we find a web page that features a box here. In the box you can input a URL, and it is claiming that once you input a URL we will be able to browse the site anonymously. Now we give it a trial and we submit the Google URL, see what we get. So by clicking on submit, because this is a simulation, the feature will not work as intended, since this is a lab, a test machine, right? Not everything is supposed to work as we wish. So that's how the feature works. You input a URL and it claims that it will give you anonymous access or allows you to browse the URL anonymously. Now if we submit again and we monitor the response, we look at the URL, we see we have url.php, and then we have a parameter called path, and this parameter's value equals to the URL that we entered. Now this actually makes file inclusion jump to our mind, but this file inclusion will not work. The only thing that will work here is SSRF or server-side request for forgery. How do we do that? So if we get back here and type something like file equal etc pass wd, so it's saying try harder. So here we're trying to access internal resources, but as you can see here, seems like the password file has the correct permissions that won't allow public visitors to read the contents of it. So we're gonna go back, and instead, since the feature here takes URL as an input, why don't we try to enumerate and find if there are hidden services running on the box. What do you mean by hidden services? Sometimes if you look at the Nmap scan, we have these open ports. In some scenarios the machine still runs internal services, but it is running the internal services in a hidden fashion, so that only those on the local machine or those on the local network in which the local machine resides are able to connect to these ports. So when you see these ports, it doesn't mean that these are the only open ports. There might be other open ports, but these ports run services locally, meaning that only those connecting to the local network are able to ping or reach these ports. So if we go back, and here we type, let's say 127.0.0.0.1, right? So if we type this, it will just browse to the local machine IP address, right? Now if we specify a port, at least we can get an idea if there is actually something running on port 80 inside the machine. Here we're using the box IP, all right? Now the box will ping itself or will try to access a page here on port 80. So if we get something, it means that the port 80 is running. So if we click submit, as you can see, nothing is here. So how can we run through all of the ports from 0 to 65, 565, and see if there are open ports running on the machine? So what we can do here, we can make or activate the purpose suite proxy. Go here and click on intercept is on, send the request. So this is the request. So what we can do here, we're gonna send this to the intruder. Go to intruder and go to positions. In the positions, I'm gonna clear all of that, and we highlight only the ports. So this is what we want to enumerate. Add. So the payload position now is at the port number. Now we're gonna go to payloads. So now in the payloads section, we select numbers, since we are enumerating ports, or we are trying to select numbers as payloads. So here we select the payload type as numbers. So it's going to be sequential from 1 to 65,535, so that every port number will be replaced, or will replace the payload position in here, so that we know actually if there is something running on here or not. Now lastly, we click on start the attack. Payload set 1 invalid number settings. So we forgot the step. So a step, we're gonna make one step. So now we start the attack, and we monitor the response in here. So it's gonna take some time. I'm not gonna leave that running. After some time, you will have some different ports where the corresponding length is actually different than 168. So you're gonna stop that and try out these ports. Now, for the purpose of saving time, I'm gonna click X on that. I guess it's clear. Discard. Okay. Now intercept is off. So immediately I'm gonna jump to the conclusion. So you will find that there is port. The port is 888. Click on submit, and as you can see, we are able to view a simple file viewer. Now, to demonstrate and make things clear, the simple file viewer runs internally, meaning that we cannot just replace port 888 and replace 60,000 with port 88 and be able to access it. For example, if we try to access this, let's take that. Let's try to access it in this way. You see, it's not gonna work, right? Because the port 88.8 is running a service internally, meaning that only those using the box or on the same network are able to access this port. So we're gonna click on X. I hope that's clear. Now we are able to access internal services by virtue of the SSRF vulnerability. Right, server-side request forgery, we are able to manipulate the path parameter and insert whatever you want here as a value, because there are no checks performed here. If there were checks, that would do validation on the value of the path. So instead of allowing everything, I would block numbers and allow only characters, so that only URLs are used are used as values for the path parameter. This way I can make some sort of filter against server-side request forgery. Let's go back now. Now, among all of these files, if you click on backup, you see there is nothing in here, right? Why? Because it's trying to access the document backup on the port 60,000, and on port 60,000 there is nothing in there, right? It's only a server running a box where you are able to browse a URL. So the only way to access the document backup is to go back and go back one more time. So we again activate, it's active. Now we make the intercept on and then submit. So we have the request. I'm gonna click on type $doc equal backup. This way we are telling the server running on this port, we are telling them that access the service running on port 8088 and fetch the backup file, which means that this method will work because I'm using the actual server, which is simple file view running on port 8088 to access the document backup, which actually exists there, right? So I'm gonna forward. Yeah, nothing here, but if you put the page source, as you can see, we are able to access the document backup. Now, down here we have plain text credentials or hard-coded credentials. Username equal admin and the password equal the password. And the roles are manager, manager GUI, admin GUI, manager script. These are the Tomcat credentials. Now, here we go. We exploited the server-side request forgery, and now you will access the administration panel of the Tomcat server. Click X on that, keep this running. Okay. Going back. So, here, what we can do, we can generate a Java payload, upload it, and receive the first foothold. How can we do that? Let's minimize this. All right. And now we go to... Okay, so using this command, guys, we generate a Java reverse shell. Don't forget to type java/shell reverse TCP. lhost is your HackTheBox IP address. lport is the port on which you will run the listener. And then we have the war. This is the extension of the file. -o, the output is shell reverse.war. Once you click or once you enter, it will generate the file or the payload. Now we go back to manager Tomcat. We upload this using the browse button, click on deploy, and then you will see the payload here. As you can see, I have it here, shell reverse. Now before clicking on triggering the payload, we're gonna make sure that our listener is running. So we check back. Okay, so this is good here. I'm gonna leave this as is. Okay, I'm gonna use another thing here. So checking up here, yeah, here's good. So nc-lvp4545, and then we trigger the payload. So here, oh, I guess I have to re-upload the payload. Okay, resend. Browse. So there we go, the payload here, open, deploy, and then we trigger the payload by clicking on the name, going back, checking on that. As you can see, we received the first connection. Now we stabilize the shell. Let's go to my nodes, and here I have the TTY. We use that to make the shell stable. Okay, so now this is the first foothold. Next step now is to conduct a privileged escalation. Okay, so ls cd home cd Athenas. Inside Athenas we have the user, the text file. Okay, we're not after the flags now. We're gonna cd back and go to Tomcat. Inside Tomcat you will have a directory called /archive. And then you have another one, pentest data. Okay, so here you go. We have two files, one.dit and one.bin. If you know the nature of both files, we're gonna have to use the file command. But judging by the look of the files or judging by the names of the files, we see we have psexec, ntds, grab, bsexec ntds grab. Seems to be that these files are related to the ntds .dat file in an Active Directory environment. So it seems that someone or the author has grabbed the credentials from an Active Directory environment and stored them here. So by typing file ** to see the nature of all files, we see the first one here .dit, it's data, and then .bin Microsoft Windows registry. So now we can exfiltrate both files to our local machine and run secrets dump to display the hashes of the Active Directory environment. Okay then, now how do you do that? So what you can do here, you can run a listener on your own machine. Clear. Okay, so nc-lvp 4546 say, and this is the first command. So in this way, we run a listener on 4546 and we direct the output to as a file. So here we are waiting for a file to be sent to my listener. The first file is the registry file .bin, and run this. Okay, when you run that, you go back to your shell here and then type cat, take the file name, okay, pipe that to netcat and put here in your IP address. Okay, I think it's clear, but I don't want to make things ambiguous. All right, anyway, so just here put your IP address in this command. It's kind of messy here. Where was this? This is the nmap scan. Okay, this is the listener. All right, here we put netcat and then put your IP address and the port which you are listening on. Once you hit enter, it will send the file to your listener here and you'll be able to grab it. You can do it the same way with the .dit file or the ntds file. Once you are able to grab them, I already did that. So next we use secrets dump. Secrets dump is a tool by Impacket to extract credentials from ntds database. So secrets dump, so this is the command -system, and then we specify the bin file or the binary file -ntds, we specify the it file, and then local. Once you run that, as you can see now, it will extract the hashes. Of course, we're after the administrator and another user, ntlm hash. We scroll up. As you can see, we have administrator and we have Atenas. We highlight the fourth field, which starts from here, and here as well the Atenas. We do the same, starts from 2. These are the ntlm hashes. Now you grab both hashes and you go to crack station. The first one is actually cracked, and this is the password. Same for the other one. Now you will take this password, okay, and change your user. Do some sort of horizontal privileged escalation. So we go back to the actual shell here. Okay, su Atenas. Type in the password. Okay then, so now we are Atenas ID. Okay, so from Tomcat to Atenas, good step. Now the next thing, from Atenas to root. So cd to home, cd to Tomcat. We actually visited that directory, no need to do that again. Cd back. So now if we try to access the root directory, surprisingly we are able to access it without any permission denied as an error. If we ls, we have the flag and we have the application log. Now as you will be tempted, you want to access the flag, right? But upon displaying the content, we see we have the statement getting closer, but what are you looking for cannot be found here. So it seems like there is another step to be done. Now we have another file called application log, and actually the author of the machine has allowed us to access the /root file in order to see the application log file. So if we cat app.log, we see we have access logs coming from this IP address. So these access logs demonstrate that there is a machine on this IP address, right, trying to access an archived file, or a compressed file on our machine. And as you can see, the version of Wget is 1.16, and everything before 1.18 is actually vulnerable to this vulnerability. So here we go, the first exploit. This exploit targets Wget before 1.18 and allows for arbitrary file upload, remote code execution. Okay, before going over the exploit, let's go back and see what does all of that mean. So see, we have this IP address, and we know that the machine IP is actually different. If we type ifconfig here, the machine IP is 10.10.10.55. But here is another IP on a different network, which means there is some sort of container running on this machine, and we can see that by highlighting the LXC-BR0. LXC is a container, by the way, container system, and you see this is the gateway IP address. Yes, so a service on this container has the IP address 10.0.3.133 trying to access something on our machine and to retrieve the archive.tar.gz file. Now if we cat etc cron tab, okay, alright, so on the local machine there is no cron job, but since these are repeated requests, as you can see here, it means that on this machine there is a cron job running as Wget running as a cron job. And since Wget is actually vulnerable here, we can take a look at the exploit now. So going over the exploit, in a nutshell, when Wget requests this file, okay, we can make Wget request another file running on different server. So what do we mean by that? So we will create a 301 redirect. So when this machine on this IP address trying to access this file, it will be redirected to an FTP server. An FTP server will be running on our own machine, the attacker machine, and it will serve a malicious file which will give us root access. That is the exploit in 3 words. But if you want to read more about that, you can read in the description. It's explained thoroughly and in detail. So as you can see, we have saying Wget will automatically follow the redirect and will download a malicious bash profile from a malicious FTP server. In this case, the malicious FTP server will be running on my machine, and it will serve a configuration file. The configuration file, if you scroll down, we will serve, let's scroll down. Okay, we will serve a file called .wgetrc. Wgetrc is a configuration file of Wget, which will instruct Wget, okay, to specify an output file. The output file name will be /etc/cron wget root shell, and then it will also post the content of the etc shadow file into post request. So when we serve this file .wgetrc in the FTP server, now if we get back, what's going to happen? The machine here will try to access this archived file. Okay, it will be redirected to the FTP server running on my machine. The FTP server will serve this file, this configuration file. The configuration file will be stored on the machine itself. Okay, And after it's stored on the machine, it will change the configuration of Wget so that it will run this shell, okay, and also it will post the content of the etc shadow file. That's the exploit in a nutshell. If you scroll down, here we have the proof of concept code. Starts from, yeah, you can copy it starting from this line all the way here. Okay, we copy the exploit code and go back to my local machine, modify on the exploit. So ls nano exploit. Okay, in this exploit we will modify a couple of parameters. The first thing, the listen IP. The listen IP will be the IP address of the interface running the LXC, which is 10.031. Why is that? Because the request is coming from this machine, okay? And if I want to redirect the request, I will need an HTTP server. So a request coming to retrieve the archive.tar.gz will be redirected, right? So this way we need to use the IP address of the LXC here. So going back, we replace that with the listen IP. The listen port will be 80, and then in the FTP host we put my machine IP address, and the FTP port will be 21. So when the request comes to retrieve the archive file, it will hit the web server running on port 80 on the LXC interface. Once it hits that port, it will be redirected as a 301 to the FTP server running on my own machine. The FTP server will serve, per the exploit, will serve the configuration file of Wget. Once it is served, it will run this as a cron job, and this is actually a bash one-liner reverse shell, which will connect back to my machine on port 4547. Okay, I hope this is clear. Now once we save that, okay, next step is we run the FTP server. Before running the FTP server, let me show you the configuration file. So ls-la, the configuration file is here, .wgetrc. We cat this, and I configured the file as per the instructions of the exploit. Next thing is we run the FTP server on my machine. Don't forget that. This is the command, and this is actually a module or library in Python which allows you to run an FTP server using Python. Once I hit enter, now the FTP server on my end is ready to serve the configuration file, which will actually, as I said earlier, make the machine run a cron job that will spawn bash reverse shell to my machine here. So we start the listener on port 4547, we will wait for the connection, and then lastly we go to the vulnerable machine here, cd to temp, and then we retrieve the exploit file. So here we have the FTP server running. We're gonna need to run the Python server on my machine. So Python sudo Python, yeah. So now we go back to the machine and retrieve the exploit from my machine. We're gonna need the IP address of my machine, which is not here. How about here? Okay, let's not waste time. Just type it config, and this is my IP. Alright, port 8000 / exploit.py. It has been downloaded, ls, and now we run the exploit using Python. A quick note, if you run the exploit on the local machine, or let's give it first execution permissions, exploit.py, and run Python exploit.py. So what's gonna happen now? The error is saying you cannot bind on ports, the listen port. You cannot do any sort of bind, and that's because we lack permissions to perform any port binding. So to make that happen, we're going to use a tool called auth-bind, which will allow us to do just as we want. Python exploit UI, and now it's running. So as you can see, serving wget exploit on port 80. So now it connected to my FTP server, as you can see. FTP session opened. Now we're going to wait a while for the exploit to retrieve the configuration file and run the exploit, run the bash one-liner, which will connect to my listener running on port 4547. Let's give it some time, because it is a cron job. Alright then, so after waiting a bit, we check the listener, we see we received the connection and we have the root access. ID, root, ls, and now we can cat the actual root file. Cat, oh, let's check the IP configuration. Command not found. Alright, so now if we go back and read through the lines here, the first thing that happened, let's go over these. So the first thing, a listener were opened on port 80, and then as you can see here, the request has come from the machine requesting the archive file. It got redirected to the FTP server running on my machine, and if you check the FTP server running on my machine here, we see we received the request and a file has been retrieved, and then the session closed. After retrieving the file, we see here we have okay, after that the file has been served from our FTP server, and here also we see the content of the shadow file has been posted, but there are no hashes in here. If we scroll back more, we see here the sending back a cron job script as a thank you for the file. So this means that the cron job has been created as wget root shell, which has actually spawned the bash one-liner, which connected back to my listener on this port, on this instance here. So I hope that was clear, and I hope the video was informative. Thank you for watching, and take care.